Today we are going to study about the transformer test. So why transformer test is performed? Transformer test is performed to know the power and different losses of our transformer. So to know about them, we need to know our different parameters. So what, there are four parameters while studying about this. So what are the four parameters? First, RO1. RO1, we all know that RO1 is equivalent resistance referred to primary winding. We can choose either RO1 or RO2 depending upon where we are taking our resistances. So RO2 is equivalent resistance referred to secondary winding. XO1 is equivalent leakage reactance referred to primary winding, or XO2 is equivalent leakage reactance. I am writing equivalent leakage reactance referred to secondary winding. Then third parameter is core loss conductance denoted by GO, or we can take reactance. Magnetizing susceptance denoted by BO, or we can take reactance either. So depending on the process, we have two tests. One is open circuit test and other is short circuit test. So actually now the question comes in mind, why we are performing these tests? To furnish the required information without actually loading the transformer. So we actually why perform these two tests? Because we come to know about the information, like without actually loading, means we do not connect any load resistance or anywhere our transformer. Without any connecting, we come to know about these parameters. So now we are going to study about open circuit test. So first we should know the purpose of open circuit test. The circuit test is to determine no load loss or core loss and no load current, which is helpful in finding XO and RO. So basically we here perform the open circuit test. Open circuit test means no load, where load is not connected. See here, load is not connected. Now after, so we all know, now we are going to study about this figure. So this figure is basically of a transformer. This is primary winding and this is secondary winding. Now apart from this figure, we have this system. This system basically we can take either on secondary side or on primary side, but here we are studying in it in primary side. Depending upon our convenience, we can take either primary side or secondary side. So now we connect wattmeter. We all know why wattmeter is used, to measure the power, and ammeter in series and voltmeter in parallel to measure voltmeter, and ammeter for measuring current. But while connecting, we all should keep in mind that high voltage winding is left open. Here high voltage winding is left open where there is no load connected, and other is connected to its supply. Primary winding, which has low voltage current, low voltage, is connected to primary winding, other is connected to supply. For now normal voltage and frequency is supplied through this source. The source is supplied. Now we all know, since we have been supplied with normal voltage, so normal flux will be generated in this winding, and since normal flux will be recorded by what? Recorded by our wattmeter. Now since we all know I naught is very small. Why I naught is very small? Because our since there is no load, so transformer will not take any effort to supply any effort to supply I0 naught. So we have copper. So copper loss is very small in primary winding, because of there some internal resistance and all internal resistance on all of this primary winding, there will be a very small amount of copper loss in primary winding, but on the other hand in very negligible amount of copper loss in secondary winding. So now we all know this phasor. This phasor is of voltage and current, and this current is of this current is I mu, denoted by I mu. The I mu is denotes what? So we know what is IW? IW is an active current which is in phase with V naught, and I mu is magnetizing current which is in phase with current. So what is the formula of power? Power is Vi naught cos phi. Cos phi is the phase difference. Now, so taking cos phi naught, and we have cos phi naught is equal to W by Vi I naught. Now I mu is equal to I naught sin theta, from where this relation can be derived, and I W is equal to I naught cos phi. Sorry, here phi naught. And now x naught is reactance. Reactance is what? Reactance is voltage in here, voltage in this winding, and upon current passing through this. What is this current? Magnetizing current. Magnetizing current passing through this winding. And now we have R naught. R naught is resistance. And resistance is how we calculate resistance: voltage upon current. What is this current called? Active current. Active current which is in phase with voltage. Since I naught is very small, so we can take I naught is exactly equal to magnetizing current. So now we have this relation. This relation is I naught is equal to V by Y naught. This quantity is very different. You may have studied for the first time. So this is the relation. Y naught is called exciting admittance. And now similarly we have another relation, exciting conductance. So what is exciting conductance? W, power that we have calculated earlier, W is equals to Vi square G naught, and G naught is equals to, similar from this relation we can derive G naught is equal to W square by V1. Now exciting susceptance can be calculated. B naught is equals to under root of phi naught square and G naught square. So these relations are basically used to derive our necessary conditions that we have studied here. Necessary parameters are derived from this relation. Now we are going to study about our second test, which is called short circuit or impedance test. Since this name is short circuit, means something we are going to short circuit. So we will study later what we are going to short circuit. Short circuit means direct connecting and having zero resistance. So it is one of the economical method for determining these quantities. What we can determine? Equivalent impedance Z01 or Z02. Z01 means equivalent impedance. Z01 means equivalent impedance referred to primary windings, and Z02 means equivalent impedance referred to secondary winding. We can determine leakage reactance X01 referred to primary windings and referred to secondary windings respectively. Total resistance similarly. We can determine copper loss at full load, and we can at full load or any load. Efficiency of the transformer we can determine. Again we can determine the equivalent impedance referred to primary winding or secondary winding. Total voltage drop referred to primary winding or secondary winding, and hence regulations. After determining all these quantities, this will help me to determine regulation of transformer. And now what we do in basically in this test, one winding, or usually the low voltage winding, is solidly short circuit. So here we have studied what short circuit test as the name suggests. So what we are short circuiting, low voltage winding is solidly short circuited by a thick conductor or ammeter. We can also use ammeter for the purpose. Why ammeter? Because ammeter is connected in series. So the emitter also you have studied in your 10+2 that it has a very thick conductor to maintain the resistance and all. So that's why an ammeter can serve the purpose here. So we can use or an ammeter. Now we draw the figures. These figures are, suppose, secondary parameters refer to primary windings. Then we will draw the equivalent figure. In this figure, a low voltage, usually 5 to 10% of normal primary voltage of at current frequency through the copper losses not is constant, is applied to the primary and is cautiously increased. Means when we apply the current, then we increase not suddenly but eventually we increase till the full load currents are flowing both in primary and secondary winding, till the full load current starts flowing in primary as well as in secondary winding. Now since this test the applied voltage is a small percentages of the normal voltage. So since the voltage is very small, so the mutual flux is also very small, so the copper losses are very small. Now the copper losses is very small, so suppose if we take the VSC is the total voltage required to circulate the rated load currents, which is, so if suppose if the VSC is the total voltage, means total voltage is supplied in the overall figure. So how we can find Z01? Z01 is reactance, impedance, equivalent impedance referred to primary winding. We can find it out by VSC by I1. Similarly, power we can find it out like W is equals to I1 square RO1, and hence we can find R01. Now XO1 can be find out by under root of Z01, like Z01 is equals, Z01 square is equals to RO1 square plus XO1 square. So similarly we can find XO1. Now the main task is to draw the phasor diagram. How to draw the phasor diagram? So phasor diagram is basically drawn here, I1 R1. Phasor diagram is basically drawn on based on this figure. Basically I1 is coming from here and then is going passing through the R1, here having the voltage drop of I1 R1, and then going to X1. Here voltage current is same, so voltage drop will be I1 X1. Now so here, come here, I current is starting from here and going to B point, having the voltage drop of I1 R1 with phase resistance of 0. But now since the here we have inductive load, so inductive load voltage drop will be I1 X1, but our phase will be of 90 degree. Now again the same current is going through the current I2 is going through current, since I1 is equals to I2, the current I2 is going through the voltage drop through the R2 and having the voltage drop of R2 dash, and now same current is going through the voltage drop through X2 and having voltage drop of I2 X2 dash. So voltage first current is going through the first I2 R2, so having the drop of I2 R2, now going through the phase difference of 90 and having the I2 X2. Since these are the main lines, now this triangle we can draw the, we can have a equivalent resistance. We know if we divide the whole figure in bit by bit and triangle by triangle, we can have our equivalent resistance. Since I1 is the I1 R1 is the one load resistance and it is the reactance. Now we can have the equivalent of Z1. We can have the equivalent of Z1. Similarly, if we consider in this triangle, if we consider this triangle, so here we have the load resistance and load reactance, so we can have the total drop of Z2. Now if we consider this whole paragraph, whole line starting from here, from here to here it is I1 R1, and from here to here is, since this is the opposite side, so I2 R2 here, so this will become R1 plus R2, and here it is I2 X2 and I1 X1. So total we can have the total reactance of equivalent impedance, or we can derive from Z01. So Z01 will automatically be equal to R1 plus R2 का whole square plus X1 plus X2 का whole square, and hence the Z01 and Z02 can be determined. Z01 can be determined and hence all the parameters can be determined. Thank you for watching this video. Please give a thumbs up if you like.